All right, so now we finished all the basic stuff. Like, it's not basic, they're still pretty hard. But the stuff we learned last week was a build up to this, because now we're going to use these concepts in today's lesson, especially divisibility rules. Very important. Right? So today's lesson is going to be on prime numbers and prime factorization. Do you know what prime numbers is?
Prime numbers like 1, 3, 5. Oh, something that's divisible by 1. Something that's only divisible by the number and itself.
Very, yeah.
Prime factorization is, let's say I have 18, I would do 3, 2.
3 squared, yeah.
And then 3 squared and then 2.
Yeah, okay, good. So you understand that. But we're going to learn these concepts and go pretty, even if you don't know, it's not that big a deal.
Wasn't this one the homework? This is the exact homework though. Yeah, I've got that for right here.
The homework is...
This was homework.
Wait, what? No, it wasn't.
I didn't do it on the sheet, but
Oh, maybe you did the handout instead of the homework. This is the homework. It's different.
No, but this was 12. That one was 12 pages. I did.
This is all the 12 pages.
Oh, I think I know why. Because the homework, when it said there was like another attachment up there that
Oh. Oh.
But
Oh, that's my bad. Let me see what I did.
because my brother was asking me which one to print out.
Oh,
I think that's where you are.
that's probably why. I'm sorry.
Is that-
Wait. Oh, that's this. No way.
What do I do when it says example? Do I just write something? What do I write?
Example means we're going to go through it together in class.
Oh, that's what I had.
And exercise means you do it yourself.
Oh. Because I was like, why does it have so many examples? And then I was just skipping one of them.
Yeah. Oh, that's why. Oh, I think I might have accidentally added it. I think I got rid of it now. Yeah, that's my bad. Okay, sorry about that. So, you have a start.
Yeah.
Yes. So, prime number. You go through prime numbers first. Then after that, we're going to go to prime factorization, which is a bit more, a little bit of a more advanced topic, right? So the basics of prime. So prime number, like Sachin said, is a number that is divisible by exactly 2, and unique means it can't be the same. 2 positive integers, right? And it's got to be 1 in itself, because always one's a factor of any number, so it's going to be divisible by 1 and itself. Cool. So also another thing is prime numbers are also called the building block of integers, and you see why that is later, especially when we get to prime factorization. So I'll give you some examples of prime numbers, right? Is 3 a prime number?
Yeah.
Why is that?
That's 3 and 1.
Yeah.
Because
Any
it
other?
was divisible by 1 and 3.
Yeah, 1 and 3.
No.
Yeah.
No, but if it's a prime number, that doesn't that mean it can't be divided by anything else except for 1 and 3?
Yeah. And if you look, there's only 3 numbers check, right? 1, 2, and 3. Clearly 2. Right? Because
2 can be divided. 2 can be. Oh.
No, I mean we're checking for 3 right now, not 2. So for checking the divisibility of 3, we check 1, 2, and 3. 1's divisible, 2 is not divisible. Actually, we'll go through 1, 2, and 3. 1 is good, obviously. With any number is divisible. 2, 3 divided by 3 is not a whole number. So it's no. And this also no. Also yes, sorry. So that means there's 2 factors exactly, or two numbers is divisible by, and it's a prime. Take a look at another number like.
If more than 2 numbers can divide that number, that means it's not a prime.
Yeah. Say if you look at 7, is that prime?
Yeah, 7 and 1.
7 and 1. Yeah, and we go through all other numbers from 1 to 7, right? Does it make sense? For we don't need to check any bigger numbers, right? Because they can't be divisible, obviously.
Yeah.
But 7 can't be the multiple of a number that's bigger than it. So obviously no. So here we check 1, right? 7 is not divisible. Yeah, good. 7 divisible by 2? Yes or no? No. 3?
No.
No.
It's no for everything.
No for everything. 4? No. 5? No. 6? No.
No,
7.
no. 4 times 4 can be 2 times 2.
Yep, I agree.
Oh, wait, no, sorry. I thought the x's meant prime.
Oh, no, sorry. We're not checking if these are prime. We're just checking 7. We're just going through the numbers from 1 to 7.
Oh, okay.
Yeah. Okay, here's the important one. Is 1 prime?
Neither.
Yes?
It's neither.
It's
Yeah,
not.
it's neither.
It's a trick.
It can't be divided by, it can only be divided with one thing.
Yeah, so it's not 2. So it's not prime. And it's not also this new thing we're going to learn next, which is composite. So this is actually special number. 1 is neither prime nor composite. Because it only has one factor, 1.
If it's like every other number except prime.
And 1.
It's like 4 are prime, 6 are prime, 9 are prime.
Yeah.
Like everything except 1, 2. Yeah.
Yeah. So I'll define composite properly first, though.
There's more than 2.
Yeah.
You know, what if there's a number? What if like every number can have like a somewhat prime? So like 9 point something makes it a prime.
Well, no, because primes are only defined for whole numbers.
Oh, okay.
Yeah. So yeah, that's good. It's good to be curious like that. But like we only define primes for whole numbers, so it doesn't make sense to think of primes with like decimals and stuff.
Yeah.
Yeah. No, it's good. Good question to ask. All right, and the next one is the definition of a composite number is a number that's divisible, not divisibility, it's divisible by more than 2 unique, as in they need to be different, positive integers. This also means that if there's got any other, because we always know 1 in itself is a factor, right? Is divisible. So if any other number is divisible by a number, then it's composite. So for example, let's take a look at a composite number, 4. And we need to go through 1, 2, 3, 4, right? Because that's only all the possibilities.
1 and 2 goes and 4.
Yeah. So here, is 1 divisible by 4? Yes. Yeah, it's 4. 4 divisible by 1. Element. Yeah.
Yes.
Yeah. 4 divisible by 2. Yes.
No.
3. No.
Yes.
4. Yes. Right. So that's 3. That means 3
Wait,
factors.
we were talking about prime numbers before.
Yep.
So would 2 be a prime number because the only numbers that go into 2 are 1 and 2?
Yep. Exactly. 2 is a prime. Very good point. Yeah. Yeah. 2 is weird because it's even. It's actually only even prime. It might be a bit weird, but 2 is only even prime number. Every other even prime number has 2 as a factor. Yep.
4 would.
No, because 1, it'll be 1 and 4, but also has 2 as a factor as well.
So for a prime number, I only have to have 1 and 4.
Yeah.
Or
But
1 and itself.
yeah. Right. It's good you're asking this because right now you're trying to get your head around this concept. So once you get your head around this concept, this will be instinctual. But for now, it's good to ask all these questions. And then I'll give you another one. A question I'll ask you. 12. Or prime.
No, it's not it's a composite because it can be divided by 1, 2, 3, 4, 6, and 12.
Yeah. Plenty of numbers actually. So you go from all these numbers, take a look. 1 is good, 2 is good, 3 works, 4 works, 5 doesn't work, 6 works, 7, 8, 9, 10, 11 doesn't work, 12 works. Got a lot of factors, right? So not prime. So does the concept of prime numbers make sense?
Yep.
All right, good. Now, I want you to do an exercise on your own. I want you to list all the prime numbers as less than 20. So I'll give you guys about 3 minutes or 4 minutes to do this. Where's the hint? Oh, it's hint in the next page. I misprinted it. You might not need the hint. Two first.
Okay. I think I've got it.
Oh, good. All right. Another minute or so if everyone else is finished. We'll discuss after that, okay?
Okay.
challenges.
What is that?
Page. If you finish early, actually, I forgot to say. Go to page 22. Some challenge problems there. So get started on those because we probably won't go through them in class today. But what I'm gonna, I might do is I might if I have time record me doing them. So you give them a go there because these are the questions where you learn the most from. So you finish early, go to do the challenge problem. They're on page 22, the first one.
So do we just answer the questions on page 22?
Yeah, while you're waiting, that's usually a good idea.
Okay.
Just because it's even odd doesn't mean it's fine.
Yeah.
You could check some of these ones. Wait, All right, we'll discuss this now. It's fine if you haven't finished yet. Because the important thing is you sort of check each number. So we're gonna list every 5 numbers that's less than 20. So the first number, obviously 1 doesn't work because we said before 1 is neither. But 2 is 2 prime. Actually, you know what? I'm gonna list the numbers. I'm gonna circle the ones that are prime or not. 1, 2, 3, 4, 5, 6, 8, 9, 10, 11, 12, 13, 14, 15. No. So one, only one factor is not prime, so no.
So 2, 3, 5, 7, 11, 13, 17, and 19.
Very good. These are the ones. And there are some ones that seem like they might be prime, but they're not. I think 9 might be tricky one. Right? 9. 9, if you go through, you choose 3. 1 and 9 are factors. Go see that's 3. 3 as well. So that's 3. That's not prime because of that. Does that make sense? Why 9 is not prime? Yeah.
Yep.
So you might be realizing that checking for a prime is kind of long for a big number though. You need to go through all the numbers. Like if I want to check prime for 19, right? If I want to properly do it, I need to go through all, if I need to be fully 100% sure, I need to go through all the numbers from 1 to 19, 1 to 20, 1 to 19. You probably stop after like a few numbers, but because you already can tell it's prime. But if you want to be 100% sure, you need to go through all the numbers, right? And see if it's divisible. I'm guessing you guys didn't do that because you're pretty quick. But because you might have already seen primes and sort of comfortable with it.
Yeah.
But like at the start, the most way to be 100% sure is go through each number. So you go through 1, check the divisibility. Yes. 2, check. You see that none of them actually work. Blah, blah, blah. Check each one of them, right? And you cross them off one by one. But that'll take a long time. So we've got to figure out a way to make checking for prime numbers easier. Because what if I'm gonna ask you this, right? I want you to check whether 293 is prime. How would you know?
293.
Yeah.
Because it can be like divisible by 3.
Not 3.
14.
The digit sums 14, so it's not divisible by 3. It will take you a long time. You have to check a lot of numbers. The answer is it actually is prime. Right? Actually, let me check. I need to be 100% sure. Yeah, it is prime. Right? So there's a shortcut way to figure out if it's prime. It's still not super sure, but there's a shortcut that we're gonna learn now, right? Shortcut. So because going through one by one is gonna take, you're not gonna check 293 numbers. Right? So we're gonna learn a few shortcuts to figure out whether the number is prime or not. Does that make sense what we're trying to get to? Like our current method's really long and like takes too time consuming, so we're trying to get to a shorter way to figure out if a number is prime.
Yep.
Is that goal clear?
Yeah.
Yeah. Okay. So we'll still practice the old method though. Our next goal is to check whether 29 is prime. We're gonna go to the short, long, annoying, like old way. Is 29 prime? 1, 29, yes, obviously, but 2, 3.
It doesn't work.
Yeah, so if you go through all the numbers, that's 1, 29, none of the numbers actually work. So it is prime. Only these two will work. Right? But that's just, we're probably not going to be able to go through all the numbers, but if you go through all the numbers and you see, it is prime. But we're trying to be more efficient because we don't waste our time. In math, the goal is to save as much time as possible. So we're going to learn a shortcut way to figure out how to see if we're going to go through this example together, right? So in this example, Mina is trying to determine whether 113 is prime. So she's doing it by checking 113 for positive integers starting with 2, because 1 obviously works, right? So her goal is to see whether 113 is prime, which is kind of a big number. We see how quickly she gets to it, right? So she thinks that 113 is odd. So it's not divisible by 2, right?
No.
Yeah. And checks if 113 is divisible by 3. How do you think she does that?
Oh,
By 3?
by 3. Adds all the numbers and then it's 5. And
Yeah, digit sum, right? So digit sum. She checks digit sum. Sees that it's 5 and it's not divisible by 3. Does that make sense? How to check 3 and 2 quickly, right? So then she knows that it's not divisible by 2 or 3. And then, okay, here's what we're doing first together is Mina says, since 113 is not divisible by 2, she also knows that it's not divisible by 4. Is she right to say that?
Yeah.
Why is that?
Yes, the last number has to be even, and 113 is odd.
No. She's not checking the divisibility rule.
Oh.
She's just checking, since she knows 113 is not divisible by 2, she's saying because of that, I can immediately cross out 4.
Yeah, because 2 is even and 4 is even. No. It's like
it's even more general point. In general, if a number is divisible by 2, not divisible by 2, it can't be divisible by multiple of 2 either.
Oh, that's what I was trying to say.
Yeah.
Trying to explain it.
Right? So like if it's not divisible by 2, it won't be divisible by 6.
Mm.
Won't be divisible by 8, won't be divisible by 10. So any multiple of 2 is not divisible by. Does that make sense? So yes, she's correct because it's important to understand why though. She is correct because if a number isn't, so understand this reason. If a number is not divisible by 2, it's also not divisible. It is also not divisible by a multiple of 2. So not just 4, it's not divisible by 6, by 8, all those numbers. But this doesn't just apply to 2. If it's a multiple of 3, it's not a multiple. It's not divisible by a multiple of 3 either. Does that make sense?
Yeah.
Multiple of 2. Any questions with this statement, with this sentence? It's a very important point. This will give us a big shortcut. And I recommend you writing this down as well. Right. And for B, hopefully you guys can read it. Right. And for B, Mina knows just by looking at it that 113 is not divisible by 5. How does she know that? Yep, Ima?
Because I would know that 5 can go to 100.
remember the divisibility rule is even quicker?
To add 1 plus 1 plus 3.
No, that's for 3. Divisibility rule for 5 is to check the last digit.
5. The whole is 0, 5.
Yeah. So it's not 0 or 5. So the last digit is not 0 or 5. That means it's not divisible by 5. So that's why she knows. The reason is last digit is not 0 or 5. And then she then says, since 130 is not divisible by 2, I know that it isn't divisible by 6. Is she right? And why or why not?
Yeah.
Feel free to answer this one. Yep. Yes, like the mouse said. So those of you guys online, you can chime in. This is discussion, so anyone feel free. Yep. And why? Or actually why?
Because if 2 isn't divisible by 113,
yep,
after all, like the thing you said, if you just add 2, like 2 times 3.
Or multiples of 2, yep.
Yeah, and then the multiple of 113.
Yeah, perfect. So the point is, because 230 is not divisible by 2, it's not divisible by a multiple of 2 either. So it's not divisible by 6. Yeah. Is that clear for everyone?
Yep. Clear.
Yeah. And then D and E. Okay. For 7, there's no divisibility rule. So what she does is she just divides it by 7, just a long division, and she finds the remainder of 1. So because the remainder is 1, you can do it on your own, but you will get a remainder of 1. So she knows that 113 is not divisible by 7. Makes sense, right? You need the remainder to be 0. And then she says, I don't have to test 8, 9, or 10. Because she knows that 113 isn't divisible by any of those. How does she know without testing? How does she know whether that 8, 9, and 10 aren't divisible by any of those? It's very similar to the points in A and C.
The 10 has to be a 0 or a 5.
No, not you're testing it now.
Oh.
She says she doesn't test it. It's because she knows that it's not divisible without even testing. Why is that? Go back to the previous parts, A and C. Is 8 a multiple of 2?
Oh, yes.
Because 8 is a multiple of 2. Because we know it's not divisible by 2. It can't be divisible by 8 either. Does that make sense? And 9? 9 is a multiple of
3.
3. And we already tested 3. Does that make sense? And same with 10. 10 is a multiple of both 2 and 5 that we already tested. So that means 8, 9, and 10 are all, we don't need to test because they're multiples of numbers we already tested before. Therefore, they're already not divisible.
When I did this at home, I wrote because 8 and 10 is even and 9 is not going to work because the last number is a 3.
Yes, but she says she doesn't test at all.
Oh.
So you need to figure out why she doesn't need to test them at all. So the reason she doesn't test is because 8 and 10 are multiples of 2. 9 is a multiple of 3. Yeah. Right. So is that clear? Makes sense?
Yep.
All right. And then finally she says 11 squared is 121, which is bigger than 113. Right?
Yeah.
11 squared is 121. Do you agree with that?
Yeah.
And then that's bigger than 113, right? That means she says she doesn't test any more numbers.
Yeah, because if she goes higher, the number's going to be higher and you can't do that. Because if you go higher than 10, it doesn't work.
Why can't you go higher than 10 though? What's the reason?
It's like 11 squared is, and then 10 times something, let's say 10 wasn't that, it wasn't 10 then.
Let's say a bigger number is multiple, right?
because it can't be, and then the bigger number is multiplied by small, like something, it can't be 113.
Okay, I think you sort of get it. I'll explain it, right? Here's the reason. Because 11 squared is 121, right? 11 times 11 is 121. That means if 11 is a factor of 113, right? It needs to be multiplied by a smaller number. Does that make sense?
Yeah.
Like 113 divided by 11. If that was, it's not a multiple, but let's say hypothetically it is.
Yeah.
It is a multiple. The answer needs to be a smaller number than 11.
Yeah.
And if it's a smaller number, we've already tested for it. So if it's like 12 we multiply by a small number that we already tested. So we don't need to check 12.
Yeah.
Because remember, they come in pairs. Like 100, like say 84 divisible by equals 12 times 7. Right? 12 is divisible, but it comes in a pair of numbers, 12 and 7 together. So if you check the divisibility for 7, you don't need to check for 12 again. So what it's saying is, if you have a number bigger than like 11, if it is a factor, it's going to be divisible. It's going to be paired with a smaller number that we already tested for. Does that make sense? It's a really tricky, really complicated, a little bit weird point to get your head around. But let's say hypothetically, there was a bigger factor of 115. Then it would need to be paired with a smaller number, and that smaller number we already tested for, so that number can't exist. Does that make sense? So we only need to check till the square of that number smaller than the number itself. So actually, we'll work this more clearly. So there's two clear takeaways we need to learn from what Mina has done. Right? So the first one is, if a number is not divisible by a prime number, right? Then it's not divisible by any multiple of that prime. Make sense? So you don't need to check 3. You don't need to check. You don't need to check 4. You don't need to check 6. You don't need to check 8. You don't need to check 9. Right? Does that make sense? Hey, Oliver. There's a little bit of background noise. It's a little bit distracting. Do you mind?
Yep, sorry.
Thank you. All right. So that means to see if a number is whether or not a number is prime, we only need to test if the number is divisible by prime numbers. Does that make sense? Because if any other number is already a multiple of a prime number, like for example 9 is a multiple of 3. That means you don't need to check 9, because if it would have been tested, if you checked 3, then it wouldn't be for 9. But this is only checking if it's prime, right? Right, because if we check for 9, right? If we already checked 3 and it's no, that means it's not possible to be divisible by 9 either. If it's not divisible by 3, it's not divisible by 9.
Yeah.
So we need to check that again. That's an important point. Try to wrap your head around that. This is not an easy topic. Please ask any questions if you have any. So I'll give you another example. If a number is not divisible by 5, it's not divisible by 15 either. So you don't need to check 15 if you check 5. And if you check 5 and yes, you stop there, right? Because it's not prime. You don't need to go to 15. You just stop. If you got to 15, it means none of the other numbers before worked. You check if it's prime. Let's say we think like this. You're trying to check if a number is prime, right? Let's say you get to 5. None of the numbers before were divisible except 1, obviously. You get to 5, and it is divisible by 5. What do? It's not because it's divisible by 5. It's not prime. Therefore, you stop there. So the only way you get to 15 is if it's not divisible by 5, right? If you keep going after 5 until 15. But at 15, you don't need to check at all. Because if it's not divisible by 5, we already know that. It's not divisible by 15 either.
Yep.
So hopefully this will make a little bit more sense of a few examples. Right, that's the important concept. And the next one is, to check if a number is prime, we need to test if it's divisible by prime whose squares are less than or equal to the number we're testing. So for example, when checking whether 93 is prime, we don't need to check if 93 is divisible by 11 Because 11 squared is equal to?
121.
That means if 11's, let's like say hypothetical 11 is a factor, 11 would need to be multiplied by a small number to get to 93. Because 11 multiplied by 11 is 121. So the 11 multiplied by something to be 93 needs to be a smaller number. That's an important point. Try like 11 times 11. 11 times itself is 121. To get to 93, 11 would need to be multiplied by a smaller number. And that smaller number is already tested before. So we don't need to test it again. So that's the important points here. This is a tricky point. But now we'll put this knowledge to practice. So we're going to practice this by checking whether a few numbers are prime or not. So recall, actually, in general, I'm going to recall a few things from last week. To check whether a number in general is a multiple, we should check by what? How do we check if a number is divisible by another number? If you don't use divisibility rules. If I want to check 252 is divisible by like 17 or something.
Oh, divide.
Yeah, do long division. Long division and check remainder. Check if remainder equals 0 or not. But another way to see if it's so check whether the remainder is 0. But a shortcut way for especially small primes is to use divisibility rules, right? For example, to see if a number is divisible by 2, what would you do?
Even.
Yeah, check the last digit. What about 3?
Add them and then see if it's divisible by 3.
Yeah, see if the digit sum is divisible by 3.
And then for 5, if the last digit 0 or 5.
Yeah, last digit 0, 5. Okay, I want to ask you another quick little thing. Why do you think I only put these 3 numbers? Why do you think I didn't put 4, 6, 8?
2 and 2 is 4. And then 2 and 3 is 6.
Yeah, exactly.
5 and 3
Yeah.
is 10.
So 4, 6, and 8, 7 no divisible rules. 4, 6, 8, and 10. We don't need to check. Because if we're checking with primes, if we check these 3, we don't need to check for these ones because these aren't prime. Does that make sense? Now we're going to practice this. So we'll do an example first. We're going to, right?
Oh, just like this.
We're going to check if 89 is prime. And after that, I want you to do a few examples on your own. Right? So together we'll do this one, and after that, I'll let you guys do this one on your own. But first, we'll do the example. Our goal here is to check if 89 is prime, right? So check if 89 is prime, I'm going to go through all the prime numbers until we reach sort of a certain limit, right? So I'm going to write down prime numbers 2, 3, 5, 7, not 9, and 11. I think 11 squared is bigger than 89, so I don't need to check anything beyond this. Right? 11 squared is 11 times 11 is, I think it was 121 before. Yeah. We can stop here. Because if it's 11 or bigger, that means the other factor will need to be smaller, and that means we've already checked it. Right? So now we're going to go to 2. Is 89 divisible by 2? God. What about 3? Right? Because it's the digit sum is 17, not divisible by 3. 5? 5, no, not 0 or 5. What about 7?
No, because that's long division 1 and then
Long
29.
division. Yeah.
7 times 12, and then I just kept on
Yeah.
there.
I didn't do long division, I just did it in my head.
Yeah, good. I mean, either way, I mean, when it's bigger numbers for a long division, but here you can do it in your head as well. So 7 times 1, 7, 1, carry the 9, 19. And 19 times 7 goes into 19 twice, 14. The remainder is 5. Right? Since the remainder is 5, it's not divisible by 2. And we can stop there because 11 squared is too big, so we don't check there.
Yeah.
Right? So it is prime because of this. And look how many numbers we tested. We only tested 4 numbers, and the 5th one we check if the square is too big or not. So look how quick that was. We only had to check 4 numbers. We only had to check the prime numbers until the square of the primes is bigger. Like we don't need to check the other prime. We don't need to check 13. We don't need to check 15. We don't need to check 17. Does it make sense? But we don't need to check these.
Yeah, because it's too big then.
Yeah. What about everyone else? This is the key point. Do you understand why you don't need to check these three numbers?
And then the other number would be too small, like very
Yeah.
small, and you would already check that.
Nicholas,
Yep.
Oliver, make sense?
Yep.
Yep.
Yeah.
It makes sense.
Ima? Yep. All right, now time to do it on your own. We'll do A, C, and let's do F. What's yes mean?
Oh, it's prime.
Yeah, you only need to do A, C, and F, but if you finish early, do B, D, and E as well. So we'll discuss this in about 5 minutes. If you have any questions, let me know.
No, 14.
What is it?
Oh, I think it's 11. No, from 11. 13, 14, 11. Yeah, it's 13 and 11.
Yeah.
Should I do this one?
Yeah, go for it. You finish all the challenges?
Where's the show?
22.
So do we only do A, C, and F, or do we do all of them?
You do A, C, and F, but if you finish early, do the rest.
Okay.
We'll discuss at 9:05. I mean, at 10:05.
Hang on. Pardon. I need a bit of help for A.
Okay, yeah. So, do you know which primes you need to test?
Pardon?
Like, to see if 61's prime or not, you only need to test a few numbers. Do you know which numbers to check?
61 is not prime.
But do you know which numbers to check, like, if it's prime or not? Like, when we tested the 89 was prime, we checked with 2, 3, 5, and 7.
Yep, 2, 3, and 5, and 7.
Yeah, it's the same for the 61, right?
Yeah.
Why not 11?
Oh, because 11. Okay, what are you doing? Sorry.
Sorry, so what were you saying before?
I'm just having a bit of trouble with A.
Yeah, but like, why not? Why do you not need to test 11?
Because 11 is not. Hang on, I just forgot. I didn't write down the reason.
So the thing is, if 11's a factor, right? Let's say if 11 was hypothetically a factor, the other number would need to be smaller than 11.
Yes.
And if it's smaller, we've already tested it.
It doesn't work. Oh, okay. Yeah, sure. Yeah.
So that's why. That's the reason. So you only need to check this one, and check if it's divisible by all 4 of these numbers. And if it's yes, if any of them work, it's not prime. If none of them are divisible, then it's prime.
All right.
Remainder 2. Not divisible. Prime is if it is.
It had to remain.
This remainder is not divisible. Prime is non-divisible, so could be prime. Like prime to see if it's prime is only divisible by one and one in itself, right? So we need to check if the numbers in between are divisible or not. We do the digit sum. It's not divisible by 3. It's not divisible by 3. That means it could be prime. So does that make sense?
Like,
Like
What do they mean when they say circle out the smallest numbers or the first stuff?
I'll get back to you. I'll just have to explain it to you after. Get back to you.
Okay.
Eventually, another question. So let's see. You do the digit sum and divide by 3. And you do the division. It's not divisible by 3, right? That means is the number divisible by 3 or not? No. So if it's not divisible by 3, it could still be prime. Because we check if it's prime, only a 1 and itself is better. If it's not 3, it could be like you need to check other primes to see if they are divisible or not. So actually write down before we do these questions, I recommend you write down all the numbers that you need to check test for. Now for this one, well, that's not enough. Because you only keep going till the square of the prime is smaller than 143. And would you go to the next prime? It's 13 squared than 143. So you can check test for all 3 numbers, all 4, so 5, sorry. All right, we'll go through these now. So hopefully. So for A, for 61, to see if it's prime or not, we only need to check 2, 3, 5, 7. Because next one, 11 squared is too big. Right? And if you go through each one of these numbers, 61 divisible by 2, is odd, so no. Is it divisible by 3?
No.
6 plus 1 is 7, not divisible. The digit sum is not divisible by 3, so no. Is it divisible by 5?
No.
No. Is it divisible by 7?
No.
7, we can check. 61 divided by 7. I think that's
7.
8,
no,
remainder 5.
Yeah.
So it's not divisible by 7 either. 4 crosses. That means it's not divisible by any primes other than. Yep, Iman, do you have a question?
No.
Okay. It's not divisible by any primes, so it's only divisible by 1 and itself. That means it is prime. Right? And for C, 143, the numbers we need to test are 2, 3, 5, 7, but also this time we also need to test 11. Why 11?
Because that number is bigger than 121.
Yeah. 11 squared is 121. That means if 11 is a factor, the other number, a bigger number could be a factor as well. So 11 we test, but do we test the next prime, 13?
13 is 169, so no.
13 squared we don't test because 13 squared is 169, which is too big. Right? So we stop at 11. So even with such a big number, we only have 5 numbers to test. And we test 143. Is it divisible by 2?
No.
No.
2.
Is it divisible by 3?
No.
No, right? Digit sum is 8. 8 divided by 3. That's remainder of 2, so no. What about 5?
No.
No. But last number is not 5, is 0. What about 7? 7? No, right?
7, no.
If you do, I think the remainder is 3. 14 goes into 7 twice exactly, so 0, 3. 3 is the remainder. So yeah, 7 doesn't work either. But is it divisible by 11?
Yep.
Here's what we need to check.
11 and 3. I mean 11 and 13.
11 actually is divisible by 143. Because if you check it here, 11 goes into 14 once, 1.
And then the 3 remain the 33 divided by
33.
11.
Is 33 divisible by 11?
Yep.
Yeah, it goes into 11 3 times exactly. The remainder here is 0.
Yep.
That means it's divisible by 11. That means this is not prime. So it's no, not prime. Even if you didn't get the answer, how we did it makes sense. It's the important thing.
Yeah.
right? So you check the primes and you should go through each one of them. And look, it's only very few numbers, 5 numbers. Even it's 143. Right? And what about our final answer, question F, 277?
Yes.
And which numbers do we need to test first of all?
Uh,
2, 3, 5, 7, 11, I'm guessing, because that's smaller. That's for the previous number. Do you go up to 13?
yes, past 13,
Yeah.
14.
No, we don't need to. We only check primes.
Oh,
So 14 we don't need. 15 was not prime. 17 is the next prime. Do we need to check 17? Sorry.
No, we have to test this. I think it's 249. Oh.
Do we need to check 17?
I think I have to. Is it 17?
Squares get really big really quick.
11, 7, 1, 9, 8,
17 squared is actually
289.
289. It's bigger. So we don't need to test 17. Right? Because if 17 is a factor, the other number will be factoring with it will already be smaller. We don't need to test that. Right? So 17 we don't need to test. Because 17 squared, if you check it, is 9, 4, 7 plus 7 plus 1, 7 plus 4, 11, and 17. 9, 8, 289. That's bigger than 277. 17 we don't need to test. Right? So even with this huge number, not huge, pretty big number, you only need to test 6 numbers to know if it's prime or not. And just go through each one of these and test them. Right? And the first is really easy to test. 2 obviously not, right? 3 obviously not. 16. 5 obviously not. 7, 11, 13 you divide and you check.
13 doesn't work.
Yeah. And if you check, you see that none of the numbers work.
Yeah.
Right? 277 divided by 7 will have some, I think the remainder is 4 maybe. No, I don't know. Yeah, I think it's 4. 3, 21. Whatever. None of these will work. So
It's fine.
spend in your times, check if these 3, none of these 3 will work, then which is not, it is prime. The answer is yes, it is prime. Does that make sense? Yeah, but does it make sense? Well, we don't need to check that many numbers.
Yeah.
Right. And another, for the answer to other 3. B, the answer is no, composite, sorry. Yeah. E, 157, yes, it is prime. The E, the answer is neither. It's neither composite or prime. Right? So any questions with those?
What's the button?
Yeah, sure. Questions with these concepts? With how we did these? Get it? Yeah. All right. Okay, in that case, we'll have a 5-minute break and we'll restart at 10:18. We'll go for another half an hour.
All right.
Yeah.
I thought that was the new thing. What's the time is?
Huh?
The time.
10:17.
What time do you finish?
11.
All right, we'll get started again. Oliver, Niklesh, are you guys back? Or are you? Oliver, Niklesh, we're gonna get started again.
I'm back.
Okay. All right. Yeah. So, yeah. Before we get started on the next section, I just want to ask any extra questions you guys had about this, what we're doing so far.
I don't really understand the sub.
Example. Yeah, we'll go through that now. So yeah. So, oops. So we're gonna go through. You know what? We'll skip this one because it's not as important. But basically, I'll explain what's going on. I'll explain what to do, but we won't go through this. What's basically saying is asking us to circle. First thing we do is circle the smallest that's not already circled or crossed out. So circle 2, right? Yep. And then you cross out all the multiples of the number you circle. Then you cross out 4, 6, 8, 10. Crossing everything. All the even numbers. 22, 32. Everything out. Cross everything out like this. Keep going on to cross everything out. Then after that, if you crossed everything, once you've done crossing everything out, what you do is you circle. We go back to step 1, so we come back to here. So we circled the smallest that's not number that's not already circled or crossed out, which would be
3.
3. The one's not here, so it's 3. And then you go through them all, and then you do step B again. Right? You cross out all the. So that means step A. Sorry, not 1. Cross out all the multiples of 3 now. So you cross out. That's not already crossed out. So 6, you already crossed out. 9, 12, crossed out. 15, 18, 21, 24, 27. You do that. You keep going. Keep doing that. What you should end up with is, in the end, all of the. What do you think will happen in the end? What do you think will be the numbers that are circled?
Prime.
Yeah. Numbers you circle will end up being all the primes.
Yeah, because we're going through all the numbers and their multiples, and the ones that don't have multiples will remain.
Yeah. Because we cross out all the composites. You end up only saving the prime. That's what should happen. Yeah, but we'll skip this. We gotta get to the content, so yeah. And another question I want you guys to think about is, how many prime numbers do you think exist?
Infinite. Because if there's infinite numbers.
Well, just because there's infinitely many numbers and there's infinitely many primes. It's actually a really tricky problem. It's way beyond. He's right. You're right. But the reason for the proof for it is really, really tricky. If you want to know, if you want to know more about it, please ask me after class. Okay? This is a really tricky question, so it's up to you. Not really part of the course, just whether if you're interested, you want to know. Right? We can talk after class. Right? How many prime numbers do you think there are, Niklesh, Oliver?
Pardon?
How many prime numbers do you think exist? Sorry?
Unsure. I'm unsure because like
There could be an infinite amount. I don't know. That's an infinite amount. You can count to infinity and still have more.
Very good, but you never know. There's proof though. Unless it's proven, you don't know.
All right, and there's proof that infinity is not a number, and you can just do it. There's proof that you just count for like days upon days. There's a really quick proof. Takes many years, like many years to count aloud to 6 billion, and that's very small. Takes like I don't know, like 60 years ish to take down to 6 billion.
I get that, but there's a 5-minute proof you can do to show that there's infinitely many primes. It's a really tricky proof, and it's pretty advanced for this class. But if you want to know, I can show it to you after if you want. Right? Okay. Anyway, yeah, that's the thing with maths. Obviously, you can count it, and it will take forever, and you will never prove anything. But there's a proof actually that it is infinite. That's actually a really cool proof. All right. Anyway, actually, let me turn the power mode on. Now we're gonna see. Actually, we're gonna skip this problem solving time. This section you should be doing on your own, right? On top of the homework if you can, and it's an optional section, but yeah, this is where you sort of refine your knowledge, right? And I'll put this on the homework as well. All right. Next thing is prime factorization. That's the next topic, right? So in prime factorization, we're going to learn what prime factorization is first, right? Before we learn what prime factorization, we're going to learn about just general factorization, right? This page, 23. Yeah. Page 23. So when we factor an integer, a whole number, so it's not prime factorization, just factorization in general. What we're doing is we write it as a product of integers. So for example, 12 can be written as 2 times 6. Yeah, that's factoring 12. We can factor 6 further as well. 6 is 2 times 3, so you can write as 2 times 2 times 3. Right? My question for you is, can we factor 12 anymore? Beyond 2 times 2 times 3. And 1 doesn't really, you can always add a 1, but that doesn't really do anything. We're going to ignore that.
Yeah.
One, there's a reason. What do you know about these numbers?
They're all
What makes they can't?
they're all factors multiple.
What's the topic we do this week?
Prime. No, they're not all prime.
They're all prime. 2 is prime and 3 is prime as well. So we can't factor 12 anymore because all the numbers are prime. And prime numbers have only 1 and 2 itself as a factor. And obviously, adding 1 as a factor is not really that useful. Like you can always times by 1. You can keep adding infinitely many 1s, doesn't change anything. So 1's really a useless number. Right? In terms of prime factorization, 1 doesn't really do anything. Yeah. So you can't factor out 12 anymore because all the current factors are prime. So the most you can factorize is until you get all primes. Right? All current factors are prime. That's the reason. So now what I want you to do is factor 40 as much as you can. Just break it down as many numbers as possible. So I want you to do that on your own. Can you factor 40 as much as possible?
So if it's 2 times 2 times 2, do I just do 2 to the power of 3?
Yeah, but you can just leave it for now. I mean, that we'll learn later to make it shorter way. That's one we learn later, but you know that already. That's good. So let's discuss this now. 40 can be written as, I don't know, 5 times 8, right? You can start with anything. You can start with anything, in the end you'll get the same answer.
Yeah.
It could be, you could do 4 times 10, 2 times 20, but I'm gonna start with 5 times 8. Then I'm gonna see if I can break down any of the other numbers more. So what I do is I get to 8. Can I break down 8 more? Yeah. Just go 1 at a time. 5 times, just say 8 is 2 times 4. So 5 times 2 times 4. Now I've got 2 numbers that are prime, 5 and 2, that I can't break down anymore. But 4 is not prime. What can I do to 4?
2 times.
4 is 2 times 2. So I'll break it down again. It's 5 times 2 times 2 times 2. So now I've factored it as much as possible because all the factors here are prime. And here's a bit of a shortcut we're going to learn now. There's 2 repeating, right? It's 2 times 2 times 2. Instead of just writing that 2 3 times, we're going to write a little bit shortcut. We're going to write 5 times 2 cubed to the power of 3. Does that make sense? Right? It's because you multiply the same number 3 times, it's cubed. So what we've done here is, if you keep factoring numbers down until we only have what type of numbers?
Prime.
Prime numbers. We have reached a prime factorization. So what we did all along here was find the prime factorization. We break a number down into its prime factors. So 12 was broken down into 2 times 2 times 3, which is 2 squared times 3. The prime factorization of 12 is this. 2 squared times 3. And the prime factorization of 40 is this. Does that concept make sense? Yeah. Oliver, Nicholas, good?
Yep, it makes sense.
Yeah, very good. Right, so this is a very useful, you see, it's such a shortcut in such a lot of tricky problems. So we need to learn the basics of prime factorization first, though. So before we actually go too much into prime factorization, I want to say sometimes when we have big numbers, a visual aid to help with factorizing into prime factorization is to use a factor tree. And I'll show what that is later, right? But this is kind of useful. Another thing is, a prime factorization of a whole number is unique. So that means 12 has only one prime factorization, and that's this, 2 squared times 3. Same with 40. 40 has only one prime factorization, and it's 2 cubed times 5. Yep.
Okay.
And then now our next thing is to be able to write the prime factorization on our own, right? Because this is a skill we've got to become good at. Because this will help us solve a lot of tricky problems, right? So, before we do it, before we go on to find prime factorizations on our own, let's recall some things. To check if a number is divisible, so because sometimes you don't know which numbers to check, like you might not know factor immediately, you need to check some number that's divisible. I need to check by doing division. In that case, to check the divisibility, check if a number is actually you end the prime factorization at a prime number, right? But let's say the number you're factorizing is prime itself, so you need to check if it's prime or not. To see if a number is prime or not, what should we do? Check the divisibility of all prime numbers whose square is less than or equal to the original number, to the number we're checking. This is a bit of a weird, we're just recalling what we did last time, right? When we want to check if a number is prime or not, we check the divisibility of all prime numbers. Sorry, less than or equal to n. Because remember, we're trying to check if n is prime or not. See if n is prime. We check the divisibility of all prime numbers whose square is less than or equal to n. Right? Does that make sense? Yeah. So this is just checking prime. So let's just recall. But now we're gonna go together. We're gonna do finding the prime factorization of the following numbers. So we'll discuss this together. So 42, trying to find the prime factorization. So I recommend, I'm going to do it as well. We're going to discuss, but I recommend you guys do it along with me, right? Don't just listen to me, because when you do it, you're going to learn more. All right, so 842, how can we break that down? Like it's 2 numbers. Factor it.
Times 7.
Sorry?
6 times 7.
Yep, very good, Sasha and Niklesh. Oh, sorry, was that Oliver? I wasn't sure. So, That was Nikesh? Yeah, sorry. I was listening to Sachin as well. I misheard you guys. 6 times 7. Yeah, very good. And then, before we go ahead, is any of these prime? 6 and 7?
7 is prime.
7 is prime, so we can't break it down anymore. Right? That means we can only break down 6. So how can we break down 6?
7 times 3 times 2.
Just 2 times 3. No, not power.
3 times 7.
Yeah.
3 times 2.
Yeah, 3 times 2. 3 times 2 is 6. Times 7 stays. Are these numbers prime?
Yes.
2, 3 is prime? Individually, yeah. 2 is prime, 7 is prime. So all 3 of them are prime. So that means this is the prime factorization. Prime factorization of 42 is 3 times 2 times 7. Does that make sense?
Yep.
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 And now we have a prime factorization of a pretty big number here. 840 times 42, right? But the thing with 42 is we already know the prime factorization. So what I'm going to do is, so from A, we already know what the prime factorization of is. I'm going to find the prime factorization of 840 and then multiply by the prime factorization of 42 afterwards. So I'm going to factorize them separately. Does that make sense?
Yeah.
Well, how can I break down 840 into factors?
840.
Okay. Anything.
120 times 7.
Yeah, that's one way to start. 120 times 7. Right? Yeah. And I already have the answer for 42, so I'm going to leave that here. 2 times 3 times 7. Keep this separate. It's 120 times 7. Are any of these numbers prime?
7
Other than these two, which you already know. This one, right? 7 prime. So we don't need to break that anymore. But we need to break down 120. Right? How can we break down 120?
12 and 10.
12 and 10, very good. Yes, we got these 4 prime. Can we break the other 2 prime? 12 and 10, are they prime?
No, they're composite.
No. So we need to break them down more, right?
Yeah.
How do we break them down?
Into 6 and 5.
6 and 5, not exactly. But we'll break them separately. How can we break down 10?
5 and 2. 5 and 2.
Yeah, 5 and 2. Good. What about 12?
4 and 3.
4 and 3 is 1. Yeah. 6 and 2 would also work. Yeah, but in the end you get the same answer. Multiple ways to go about it. It doesn't matter as long as it's a correct factorization. You'll get the same answer here. Okay, now we got prime. Nearly done. 4. How can we break that down? 2 and 2. 2 times 2 times 3 times 5 times 2 times 7 times 2 times 3. Okay, this is really ugly. But what we can do is make it nicer by how many 2s are there?
4.
1, 2, 3, 4. So we can write this as 2 to the power of?
2 to the power of
No, because it's not adding them up.
not 4. 2 to the
Yeah, very good, Oliver, very good. Does that make sense why it's 4?
Yeah.
Yeah.
Yes.
It's multiplication. So 4.
You were trying to go for the
Oh, no. Yeah, 2 to the power of 4. And then next one is we have, how many 3s do we have?
2. 3 to the power of 2.
3. So it's,
yeah 3. So 3 to the power of 3.
oh, it's 3 or 2?
2.
2. 3 to the power of 2.
3 to the power of 3. Sorry.
Yeah, good.
And then there's 1 5 times 5 times 7 times 4. So times 7 to the power of 2.
Yep, very good. That's our prime factorization. Does that make sense? How we do this? So
Yeah.
keep breaking it down until everything's prime. And if it gets too messy, you can combine early. If I wanted, I could have combined the 7th early at the start. Right? If it was getting too long, to make it a bit easier. Right? Break it 7 squares straight away. Right? Now I want you to do it on your own. I want you guys to do B and D on your own. And we finish, do A and B and D on your own. So Shane, don't put commas, put a multiplication symbol.
Oh.
So if you first multiplication symbol.
Do you find the answer or just
Yeah.
Six. Sometimes.
We'll discuss in 5 minutes. 10:41. Oh, no. Oh, that's multiplication symbol. That's it. Wait. No, that's good. All right. Remember something wrong there. Oops. Sorry.
I'm having a bit of and a mic.
Okay.
After nothing.
Okay. That's fine.
We have 15 minutes till the quiz.
Yeah, about 7 minutes actually to the quiz.
Oh, sorry.
Yeah.
I'm having a bit of trouble with D.
D. So for D,
Yeah.
what I recommend you do is do the prime factorization of them separately. So do the prime factorization of 288 and the prime factorization of 24 separately, and then multiply them together at the end.
Okay.
Does that make sense?
Yep.
I have a question for about D. I just divided it by 2 and then I got 1. Shall I, if it's even should I divide it by 2? It's a 44, it's a square number, so it was easier.
Yeah, we can whichever we just keep whatever you spot. Divide by that. You just keep going towards more. Yeah. There's something tricky like actually can you do prime factorization of 148? Just do it on your own. It's 148. You just be in D. Yeah. Fine. Yeah, cool.
Oh. But if I got rid of one of these, could I do it?
There's no 93 anyway.
Because like 36. If you split it up
No, 93. It's 9 times.
2,
9 times. Right, 2 squared. Just put that. Just makes it easy. Okay. There's no-
We're 5 minutes till yeah. The
Yeah,
quiz.
sorry. Oh, 5 minutes gone?
No, 5 minutes till the quiz.
Oh, okay.
So,
So, then, are you done here?
no.
Wait, keep doing it until you can't split it. What can you split 92? What can you split 4 into 15? All right, let's go through. Actually, I said 10:41, right? So I'll wait till 41. Oh, it is 10:41 now. So I'll see how you want to do that before I go to this.
Was that quite wrong?
I don't know. Do the challenge. It's really hard one at the end.
Is that page 22?
Later on. Sounds really sick. 6:27 maybe? What's the challenge?
Oh.
So how do you split that?
4 times.
So what's 9 factors of 9? 9 dot prime rows, you keep factoring it.
Oh, 3 times 2.
Keep doing that until all the numbers are prime. All right, we'll go to this example now. We'll go to the answer now. So 72. So we're gonna start. Does anyone want to give me anything you want to split up 72 to?
12 to 6.
Very good. By the way, it doesn't matter how you start it. You can start with a different number. In the end, if you keep breaking it down until it's smaller and smaller, you'll get the same answer. Right? And 12 and 6, both are not prime, so you can still keep breaking them down more. How can we break them down?
2 times 6 times 2 times 3.
Yeah, very good. 12 is 2 times 6, and 6 is 2 times 3. Okay, and we got how many primes? 2 is prime, 2 is prime, 3 is prime. So we only have 6 that's not prime. To break that down. Right? So what's 6 breaking down?
2 times 2 times 3 times 2 times 3.
6 broken down 2 times 3. So that's this. And in the end, we have 3 2s, so it's 2 cubed. And 2 3s, that's 3 squared. That's the answer.
3 times 3 times 2 times 2.
Yeah, that's it. 2 3s, 2 cubed. 2 3s, 3 squared. 3 2s is 2 cubed.
Oh, okay.
Yeah. It's just short way to write it's the cube and square. Right, and D. We'll go through that one now. But D, actually, I'll put the answers of A and C afterwards. For D, is 288 times 24. So let's break out 288 first. 288.
12
Yep.
times 24 times 6 times 4.
Very good. So it's broken 288 down to 12 and 24. And 24 is 4 times 6. Well, then do this along with this. Yeah. 12 times 24 times 4 times 6. Right? And then none of these are prime, I think, right? So we can keep breaking them down more.
Yep.
So we'll break this down.
3 times 4 times 6 times 4 times 3 times 2 times 2 times 2.
So it's halving every time, basically. And okay, I'm going to ask Imal to break it down here. Right? So we have how many primes? 3 is prime, 3 is prime, 2 is prime, 2 is prime, 3 is prime. So we've got these 4 numbers we need to break down. How can we break that 4 Imal?
2 times 2.
Yeah, that's the only way to break it down. 2 times 2. Then 6 will be?
It will be 3 times 2.
And 4 is again?
2 times 2.
Times 2. And then, it's long now. 3 times 2 times 2 times 3. How many 2s? 1, 2, 4, 5. Wait, did I mess up anything?
No. Wait, I think you're missing 3.
4 times 6 times 4. 2, 3, 4,
No,
5,
that's right.
7.
The answer is 6,912.
We're not finding that's a factorization to the 7. Wait, that doesn't look right. It should be 8.
Because if you have.
Oh, sorry. I put 3 times 2 again, so 2 times 2 is 4.
Oh.
It's my bad.
No, it's wrong because it's 2 to the power 8.
Yeah, so it's 2 here instead of. So I put a extra 3 and a minus 1. So it's 2 to the 8. My bad. And how many 3s are there?
3.
1, 2, 3. 2, 3. So it's 3 cubed. Right? It's 2 to the 8 times 3 cubed. And actually, if it gets ugly like here, what I would actually do here is I combine all the 2's together first. Before I split it up anymore, I might go like it's 3 times 4. Actually, it's 3 squared times 4 times 6 times 4 times 2 cubed. So that it's a bit easier to work with early on, and then I continue splitting further here. Right, and then you should get 2 to the 8 times 3 to the 3. And our answer for A, 30 is 2 times 3 times 5. Yep. And for C should be 2 squared times 3 squared times 7. Right. Do it on your own and see if you get this. I think that's correct. Yeah, and this is A.
Yeah.
Yeah, it's fine if you do that. It's optional. You get plenty of questions, We're gonna practice this with this homework this week. We'll have a lot of practice questions on this, so practice it with these. All right, and that's it for today's content. We'll finish the rest off next week, and we'll do the quiz now. So, Nicholas, Oliver, do you guys have access to the quiz? It should be on Google Classroom.
Okay.
And Nicholas is optional for you this week, but I mean, from the way you handle this class, it should be fine for you. I think you haven't learned it in this class, but you probably already know it from school or something. Yeah, get started. Oliver, you got the quiz?
Is it quiz 13?
Yes, quiz 13.
Okay.
Actually, let me be sure. Yeah, quiz 13, that's the one. It's just the stuff we went through in today's recap. Oliver, did you get the quiz? I will go till 11, the quiz. Yeah, and we'll finish there. No, this is a quiz, but feel free to ask any questions if you have any, by the way. How do you find the challenge problems, Sasha?
Some of them are hard and some of them are easy.
Take a look at them after if you want. Do you want to take a look at what you've done so far in the challenge problems? Also, another thing I forgot to say was after Saturday's class, I did the challenge problems on like the previous handout part 1, and I uploaded a video of it. Right?
Oh, I saw the video.
Yeah. If you guys want to look at how to do the challenge problems from the last handout, watch the video.
I have a problem with question 2. Because it's a negative. So do I go down to negative 5 and then I go negative 27 and then negative
Negative 38.
negative 38 and then do I go that way?
Yeah.
Okay.
Because it's all your first is better. Yeah, I should say.
You did the challenge as well? Okay.
Guys. About 5 minutes left, guys. And by the way, a lot of the time in the quiz, when you see a huge number, it's because the size of the number doesn't matter for the divisibility rule. In the divisibility rule questions, like
2, 6. Yes. 2, 8. Okay. 3. No. 2.